Hello and welcome everyone. So this is our introduction to rigging video. We will be taking a look at a couple of things today. So we will be working with our outliner. We will take a look at parent and child relationships in Maya. Also groups, constraints, different type of constraints. We will take a look at the connection editor and also how we can utilize set-driven keys option. We might take a look at the expression editor just really quickly. So let's go back into Maya and talk about a couple of things we have happening here on the screen at the moment. So as you can see, I have my outliner open, some objects are hidden, and I have this parent and child sphere, and just for the sake of demonstration, I made it quite obvious. This is going to be our parent and this is our child. So at the moment, as you can see, the structure of the outliner tells us that nothing is connected to anything at the moment, so there is no obvious connections between the objects. If you're wondering what those obvious connections might look like, I will show you really quickly. So you would see something like a plus sign next to the object, similar to what we can see with this initial shading group. If you open up this plus sign, you will see this tiny little line showing the immediate child of this particular object over here, and the structure can go on forever. If we, for example, introduced another child, which would be parented under this particular object over here. I will just undo this really quickly and put everything where it was before. So this structure means that all of the objects in the scene are parented under nothing, or people usually say that they're parented under the world. When you create something, it's parented under the world. But we can start parenting objects under each other. So as you can see at the moment, I can move those freely and nothing really happens. But what I can do, I can make this object a child of this big red sphere. So I will have to select the child first, shift select the parent, and press P on my keyboard. So P is for parenting, and you have to be very particular in which order you select things. And if you wanted to unparent an object from another object, you would have to press Shift P. So it's similar to, hiding, unhiding, Control H, Shift H. So it's the same type of structure in Maya. Let's do it again. So let's take this object and parent under the red sphere. So I'm just going to press Shift and hold, click on the sphere, and press P on my keyboard. So what happened now is that nothing really changed for this particular object. We still seem to be able to move it around quite freely, but you will notice that as soon as we click on the parent object, our child gets highlighted as well, meaning that we can control it with our parent sphere. So now this little guy lives kind of in the world of this big red sphere, so it's parented under it. And now if we manipulate this object, this little one will be affected as well. So if I do something like this really quickly, and then, so you will notice that nothing really changed for this child object. We're not getting any transformations, which is quite weird, right? Because if you think about it, you would be kind of expecting to get some sort of translation or rotation values on this object, but nothing really happens because it didn't change its position according to the world of this big red sphere. It did nothing. It stayed exactly where it was. What we see on the screen happened because the world itself changed. So our parent was manipulated, but this object, nothing really happened to him. It just stayed where it was before. And so let's just take a look really quickly what happens if we decide to unparent this child right now and put it kind of back under the overall world. So if I press Shift P, you will see that immediately we're getting this rotation values on our child. And you can zero it out, but you will also notice that because of the way we just handled the situation, our sphere is not actually at our original position, and there is no way to tell now where its original position was before. So potentially, if we wanted to figure it out, what we could do is to parent it back under our parent. So click on this one, shift click, and P. And what I can do now is I can press click on my parent, go back to 0, click on my child, you will see that it immediately assumes some values coming from the parent, just to be able to kind of work with the parent. So I can get rid of this. And I don't need those values anymore. So my child is exactly where it was before we parented it under this big red sphere. So I'll just get rid of history and phase transformations. So this is a really cool concept, and what we could do, for example, we could duplicate this child, and you will see that it gets parented under this red sphere by default. So I just pressed Ctrl D, and you also can kind of see what exactly objects are parented under. So at the moment, if I just follow this line and follow it upwards, and follow this line and follow it upwards, so they're sitting on the same level, so I know that both of those are children of this red sphere. Alternatively, what could happen instead, I could parent this child under this one, and that would be a completely different hierarchy. So you can see how it has changed. So now if I wanted to see the immediate parent of this child 1, and if I trace this line upwards, I will see that, okay, so it terminates here, meaning that this object is its immediate parent. And for this object, nothing has changed. Its immediate parent is still our red sphere. And so you could go on like this forever. So this is quite a cool concept. And you will see that our parent still controls both of them. But I can also do this, so my child can control 2 of those objects. And you will see that child 1 can move on its own. It's not controlling anything, but it's being controlled by the rest of the objects. Also, let's take a look at some really cool effects you can do with this sort of parenting. So I will just duplicate one of those objects really quickly, Ctrl D, and maybe snap them around here. And I will unparent this object. So I think I also by accident created an animation. So let me just click on this, get rid of this little key. Cool. And so just freeze. First of all, I want to unparent it, Shift P, so that it's not sitting under the same hierarchy. And maybe I will probably not bother with renaming it, but delete history, freeze transforms. And what I want to do is I want to create a chain of those balls going to the right. So I will press Ctrl D and move it out. And now if I press Shift D, it will create another copy, and it will move it exactly the same amount of grid squares in between them. I'll just Shift D, create a couple of those, and then I will just start reparenting them. So what I want to do is to do a similar sort of setup to what I have here. So I just want to start from the right and keep parenting them under one another. So this one will be controlling all of them, this one will be controlling only everything to the right, and so on and so forth. So apart from doing it right in the perspective view, you can also do it in the outliner, which is much easier sometimes, especially when you have a lot of objects. So you need to be comfortable working with your outliner, because imagine having hundreds and hundreds of objects in your scene. As long as they're named correctly, you should be able to find them really easily in the outliner, compared to trying to hunt for them in your perspective view or any other view. So to start parenting here, I can click on an object and then middle mouse drag it onto the other one, like so. And I will just keep doing this. So I'm clicking on the top node, is usually what we call it. So if you think about all of them as nodes, you would say, hey, parent this top node to child 7. So that would mean that they want you to select whatever is the parent, the top parent of an object, and just parent it under another. So I can click this child 7 and just keep on parenting with middle mouse dragging. So you will see that now we have this really cool hierarchy where we are controlling different objects. what we can also do, which is quite cool, and you will be using this in rigging for things like fingers or tails, tongues sometimes, even wings maybe. What we can do now is if we select them one by one, starting from the child again, from the, I guess, child, the lowest child in the hierarchy. And if you try and rotate it now, you will see that you're getting this really cool type of behavior. So you can see that this would be really useful, even for maybe strands of hair on your character. This is really cool. And imagine how hard it would be to try and do this type of movement without this parenting. So if nothing was really parented, I wouldn't really be able to achieve the same type of movement. If I were to do something like this, you will see that, you know, all of them start rotating in exactly the same manner. So parenting gives you a lot of really cool options, even just for animation, you know. So apart from using objects as parents, we can also use groups. So groups are nodes in Maya that don't really have any physical properties. They are like containers, but you cannot really see them on the screen. You can see their pivot points, and it's quite important to know that you can change the pivot point of a group, but usually they're just used as containers for other objects. So let's say, for example, I wanted to group all of those objects just to be able to manipulate them all at once. So for this, what I can do, I can drag select all of them, and I can press Ctrl G. So Ctrl G on my keyboard, and you will see that all of them get highlighted. And also, my Maya is pointing me towards a new pivot point. So whenever you create a new group in this manner, it will always create a pivot point for you, which will be sitting right in the middle of your grid, which is quite useful sometimes. Sometimes you might want to change it. So over here, what I can do, I can either center my pivot point, meaning that it will probably find the center of all of those objects. So let's see what it actually does if I press center pivot point. Yeah, so it kind of estimated where the center of all of those objects will be. Or I can manipulate this pivot point the same way you would do it with a normal object. I can move it around, do whatever I want. I can snap it to things. So from the top view, I could snap it to the middle of the sphere. I will just press V on my keyboard to activate my vertex snap. Now I just drag it around to roughly where I think the middle point is. So it's over here, and press V again to get out of this mode. So what we can do now is we can start manipulating those objects. Like so. And if we look at, into the outliner, you will see that Maya has created this node for us. So you will always be able to recognize groups because they have this kind of white paper sheet with the red arrow look. And you can open up this plus. So with those pluses, it's a useful thing to remember to press Shift before you click on them. So Shift will open everything up for you, while if you just click plus, it will open the kind of the top node of the hierarchy, I guess. So in here, for example, you will see that if I have all of them open and I click minus now, and click plus again, it will kind of retain that information. But if they were, if this particular one was closed, so I can see this plus sign against it, and I click on the minus sign, and if I open it up again, it would still remember it. So an easier way of doing this is to press Shift and hold it, and then click on this, and it will open up the entire hierarchy for you. In this case, because we only have this one level of parenting, it doesn't really matter too much. So you can just click plus and minus. So groups are really important, especially when you start working on your rigs, and you will start watching those video tutorials and working on your own character setups. You will understand the importance of having groups. They just let you do a lot of really cool things. But for now, we're just learning about them and about how to create a group. So you don't necessarily need to have anything selected to create a group. We could always just press Ctrl G. and you will see that it creates this null node, so meaning that nothing is in it, so it's null, it's nothing, right? But we could always make something like this parent, for example, and drag it to the null. And now this parent has its new parent, so the pivot points are sitting in exactly the same spot. So what I could do is change the pivot point for this particular group. It's still a group, so and now if I select it from here, that's the only thing, you won't be able to select groups from your perspective view, at least not in the way you select other objects. What you can do is you can click on any object in the hierarchy here, right? So I can click on the child, and I can start pressing up arrow on my keyboard, and it will go to the next immediate parent of this object. And if I do it again, it will select the red sphere for me, so I'm pressing up arrow again. And if I press it again, it will select my top node or this null one group, right? And so now I can start manipulating objects from here using this new pivot point. Right, so this is quite a cool behavior. So the next thing we will be looking is the constraints. So constraints are a little bit different compared to just using Maya's parent-child relationship. So we'll just duplicate this really quickly and get rid of this one. And I want them to be sitting by themselves, so I will Shift B and freeze transformations, delete history on those two. And so to be able to access constraints, you will have to go under your rigging menu. So instead of sitting in the modeling, you will have to go under rigging. And so what we can do from here is we can go under those constraints. And I'm just going to open up the option box, and we'll just take a look at pretty much all of them except for the scale and pole vector. So this is going to be the first one, our parent constraint. It will behave in a similar manner to what we had with the previous setup with the child and parent relationship, but it will be different. So you can animate constraints, which is really cool. You can say that, you know, at this particular point of my animation, I want this object to be a child of this object, and then I want to switch. And I want to say that now this guy is a child of this object. So you won't really you won't be able to achieve the same result with proper parenting. So you can do it with parent constraints or any other constraints. So parent constraint will be working with your translation, rotation, and scale values. So you will see over here that we can specify different constraint axes. At the moment, it is saying that everything is constrained. So our translate axes are set to all. Sorry. Same with the rotate. So let's see. Well, the first thing, a very important thing you will see here is that at the moment we're using this maintain offset, and what it means is that we will maintain this offset between the two pivot points of the object. So you can see that this guy, its pivot point is here. So it's sitting quite far away. It's offset from this object over here, right? If we didn't have this option on, what will happen as soon as we click add, this object will get snapped to the middle of its parent. So that's important to remember. And sometimes you can even use this. So sometimes when I want an object to sit right in the middle of another object, I will use my constraints to give me this, to help me with grabbing one object and bringing it right into the middle of the other one, or not into the middle, but to the pivot point of the other object. So another important thing to remember about constraints is that the selection order is reversed compared to parenting. So if for parenting it's child first, parent second, it's reversed for constraints. So you will have to select your parent object first, and then you will have to select your child object, and then you can add a constraint. So we'll have to select the sphere, and then we'll select the blue guy over here. We'll keep maintain offset on for now, and we'll keep all of those on for now as well. And we'll just hit apply. So you will see that straight away for our blue sphere, our translate and rotate values got highlighted, meaning that they have an incoming connection. So now what will happen is that you will see that when we click on this object, this one doesn't get highlighted, so it's not actually selected, not in the same way like what we had with those guys over here. You will also notice that the hierarchy sort of looks the same, but the child object has something associated with it now. So Maya has created a new node for us, which is called this child parent constraint 1. And this node is what is making the connection between the two of them. So whenever you want to get rid of a parent constraint or any other constraint, the easiest option is to just find the object which has it on it, find the constraint, and you can just delete it. Just press delete and it will get rid of all the connections, so you won't see them anymore. But let's take a look. So you will see that it works pretty much in exactly the same way. I can do whatever I want with this object. Nothing really happens. But you will see one difference is that this object is sort of, it will have to stay in the same position. So unlike here, where I can manipulate this object and I can do all sorts of crazy stuff with those two guys, and I can still grab my top node and nothing happens, so those guys will remember their positions. With this one, because of the constraint, I cannot really do anything with this object anymore. As soon as I start moving its parent, it will get back to where it was before, so it remembers its position over here. So let's take a look really quickly what happens if we get rid of the parent constraint and just hit delete. And instead of having maintain offset on, we will turn it off this time. And we will hit apply, and you will see that straight away our child goes right into the middle of the parent object. So if we go into the wireframe mode, you will notice that, okay, it just got snapped to the pivot point. Also, you can see that also we don't have to, just going to press 5. You will see that we don't have to constrain all of the axes of the object. So what we could do is, for example, say that we only constrain the Y and leave the X and Z alone. And let's see what happens. So select parent, the child, apply the constraint. And so you will see that, okay, this works. But if I move my sphere in any other direction, nothing happens. But I also have my rotation as well, so the rotation is still connected on all of the axes over here. Cool, and you can see that our translate X and translate Z are the only ones that do not have any incoming connections. So we should also be able to break connections from here, so I'm just selecting everything and going break connection. And as you can see, we're not affecting our child object anymore, but I wouldn't recommend doing it because we still have this parent constraint node associated with this child, so we'll just get rid of it like so. So really quickly, we can take a look at the point and the orient constraints. They are versions of the parent constraint. The only difference is that they affect only translate or rotate values. So point constraint will work on the translation of an object, but they will not affect the rotation. So let's keep the maintain, let's have this on and hit apply. So you will see that, okay, this blue sphere has incoming connections, but the rotation values are not constrained. So same thing here, you can specify which axis you want to be constrained. And let's take a look at our orient constraint. So this will be affecting our rotation values. Just really quickly, I'll turn the wireframe on. Let's hit apply. So you will see that the rotation works and the position is not getting changed. But also let's take a look at what happens if we get rid of the constraint and we turn maintain offset off this time. You will see that in this particular scenario it doesn't get snapped to the middle of the object, but what it does, it gets snapped to the same rotation values. So whatever our parent object has on will get applied to our child object. So that's quite important to keep in mind, that this might happen. Sometimes it's unwanted, sometimes you actually want to have that. So depending on what you're trying to achieve. So one thing you have to realize is that with constraints, what you can do is you can have multiple constraints on the same object coming from different objects. So for instance, I could have two spheres, and I can say that they will be parents for this particular object over here. So the way you have to select things is you kind of have to add constraints one by one. Although let's give it a go and just see what happens if we select both parents first and then we select our child last. And we'll go and create a parent constraint with the maintain offset. I think we'll do an off this time and just see what happens. Cool, so you will see that the behavior in this particular case is a little bit different compared to what you had before. So it might not be the one-to-one type of movement. Also, I've realized that I didn't actually constrain any of the other axes, which is a good thing to do a mistake like this, just to remind you that you need to take a look at what kind of options you have for your constraints first. So let's do this again. So as you can see, when we have all of our axes constrained, the object sort of jumps in the middle, into the middle of those two parent objects. And you will also notice that if we click on this one and go into our channel box, you will see under this parent constraint that we have two parents associated with the object. So it says parent 1 and parent 2. And this is just the weight 0, weight 1, and both of them have weight of 1, so they are controlling it 100% at the moment. But also because there's two of them, it just means that it's sort of any influence will be divided by 2. What we could do is we can play around with those settings. So we can say that I only want 0.2% of influence of our parent 1 and 0.8 from this guy. So you will notice that this one now controls it much better, I guess, or it has more influence on the object compared to this guy. So I have to drag it quite significantly around just to be able to see any sort of transformations happening to our child object. So this can be quite useful for animating things as well, because everything you see here can sort of be keyed and changed. I'm just going to get rid of those. So the next thing we will take a look at will be our aim constraint. I guess it's quite self-explanatory what scale does. So all I want to do here is I want to simulate something like an eyeball maybe. So aim constraint will allow us to tell an object to look at something. So I also want to create a NURBS curve for this one. Rotate it and just position it in a way where it's kind of sitting in the middle. I'm just gonna de-snap it to the middle of the sphere and go back to my perspective. And let's say I'm happy with that, and I can delete history and freeze transformations. So let's take a look at what we can do with this now. We go into our options. Cool, so this is our parent object. We'll shift select the child. And so over here it looks a little bit busy. So we need to specify what our aim vector is going to be like. So for the aim vector, I'm going to say that it's my z. So those go like x, y, and z, as I think I've mentioned before. So I will zero out those, and I will say that my z is set to 1. For the up vector of this object is going to be y, so I don't have to change anything, x, y, z. We'll leave this on as they are for now. And world up vector, it's just asking what our world is set up to. It's set up to y is up, so that's fine as well. And we can constrain x as all of them, and we'll just hit apply and see if it breaks enough. Oh, sorry, we have to actually select parent first. Hit apply. So now what should happen is that when I start moving this object around, this one will start following it, if we set everything up correctly. Yeah, so this is pretty good. So aim constraints are quite useful for things like when you're trying to set up eyeballs. So if you wanted to be able to control them, and you know you all just have 2 of them, and then you can manipulate your eyes in that way. So this is quite fun to play around. Sometimes it gets a little bit of time to just figure out what's happening over here, but we've sort of talked about it a little bit. So yeah, this is pretty much it for the constraints. Let's go back to our scene and see what are the cool things we can do. So let's say I have this object and I have this one, and we'll just duplicate this, and drag it out and unparent it. We can connect different channels of different objects to each other as well. So in a similar manner that we were using constraints, but we will be able to say that, hey, every time I move this object up and down, I want this object over here to grow in x, y, and z, or maybe in just x. So we can achieve that through our channel editor. Oh, sorry, it's actually connection editor. So with the connection editor, you have to load the object you will be working on. So let's say this will be my first object, and I will just click on reload left, and you will see that it loads all of the things that you have control over but usually don't touch. So there's a lot of things that you will not really be touching ever in your Maya career. And we can do the same with this object. We'll just say reload right, just to load it into this little window as well. And so what we can do from here, let's find our translate. Well, just over here. And you will have to click on this tiny plus icon. And let's say we want to translate our y-axis. Sorry, to connect our y-axis, and we will connect it to the scale of this object. So on the right side, we will just have to look for scale, and let's say we'll want it to be constrained on all of the axes. You will see that the object will disappear, which is completely understandable, because if you think about it, this object is it has its translation 0 out at the moment. So if we click on it, there is nothing over here, meaning that our little child object, which has become is pretty much nothing, will get those values from this guy. So if we take a look at the scale, it's scaled to 0. But watch what happens once we start to move this object up and down. So as soon as we start moving it up, our little sphere starts growing, and it's actually becoming quite massive, because we click on it, you will see that now it's scaled almost 20 times as big as it was before, just because our little parent is translated this much. So this is quite cool, you know, just for creating some crazy effects. Cool, so my mic crashed a little bit, so we'll have to recreate the setup really quickly. Maybe just show you a couple of other tricks. So basically, Connection Editor will be useful for you when you start reading as well, especially when you will be working on your reverse foot setup, which you don't really have to worry about for now. But again, just really quickly to show you how to do this again. Just go into your Connection Editor. And don't forget to load the correct things into the correct windows. And let's see that this time we want our rotate or maybe translate Y to affect our translate Z on the other object. Cool, and the translate Z on this object will be controlling maybe scale, or maybe let's not do scale this time, maybe it will be controlling the rotation of this one. Also, you will see that all of those objects have connection. As soon as I click on this one, I can see that the other ones are highlighted in this purple or pink color. And as you can see, all of them are doing their own thing when I'm just manipulating just one object. So this is really cool, especially for when you're working maybe on something a little bit more mechanic. If you wanted to have some sort of machinery setup, you could always use your Connection Editor. And let's say you wanted to get rid of those connections, so you can always just, in this case, you can just go and click on the Rotate Z and go and break connection from here. And do the same with this object. So I want you to practice this and maybe create something really cool, like a really nice word setup where things are, you know, being manipulated by each other. Just to give a go at this. And the next thing we will take a look at is set-driven keys. So one bad thing with the Connection Editor is that you cannot really specify that, you know, I only want this to happen when I move this object like so, and you cannot really specify which particular direction you want this guy to go. So you cannot say that, you know, when I'm moving this in a positive direction, I want this to go in negative direction. So for those things, you can use your set-driven keys. Let's just take a look really quickly. We can find them. I think we'll have to go under Animation, Key, and Set-driven Key, and just click on Set. So the same type of scenario where we have this driver and driven. So remember how with the Connection Editor we have left side of the screen and right side of the screen or the window, and we sort of assume that, you know, whatever is on the left will be controlling whatever is on the right. So we can say that it was actually our driver on the left and driven on the right. And we have the same type of setup here. So we have driver, so whatever will be controlling the object, the driven object over here. So we'll click on this object and say that click on load driver, and you will see that it gets loaded into this tiny little window, and we'll select this one and go load driven. And actually, maybe let's rename them as well. So this will be our driver, and this will be our driven. I'll just reload them. And let's say when I move this object up, I want this one to go, let's say maybe negative X. and when I move it down, it will go positive x, or something like that. We'll figure it out. So the first thing I will want to do, I will want to create a key for the default position. So at the moment, this can be considered a default position, right? So we'll just get rid of the transformations and make sure that we don't have any on this object either. So let's select both of them, and we'll find the channels that we will be manipulating. So it will be our translate y and translate x for the driven, and we'll say key. And then let's say that whenever I move this object up, so let's say maybe 10 in translate y, this object will go minus something in translate x. So maybe minus 7 in translate x. And we've moved them into the position, and as soon as we're happy with the position, we need to key. And you should be able to see the result of this straight away. So if I start moving my object back, our driven will go back to its default position. But when I move this down, nothing really happens because we haven't specified what happens here. We only said that we only keep this position and this position on top. So we'll just go back to the default position from here. And we'll do it again. So cool, I think it stops moving at 9. Well, I don't really remember which value it was before, but let's say it stops moving at 9. So I'll want to go into -9, and let's say that this object will be moving +8 or something like that. Cool. So again, once I've positioned them correctly and I'm happy with the position, I can go and say key again. So you will see that now, when I go back to the default position, now this object moves into the default position, and I can go up, and it will go to the left. So this is sort of similar to what we were able to achieve with our connection editor, but you get more control over what you're actually doing. So we can also hook up other things to this. We could hook up the rotation values and things like that, and we would just have to create more keys for this. So this is quite a useful setup for when you're connecting, for example, blend shapes. So when you're working on your creating facial controls for your characters and you're hooking them up to control curves, you can use set-driven keys for that. So you would be able to manipulate the controller and see something happening with the face, for example. Or you can do it for this type of setup. Cool. And again, if you wanted to get rid of it, just go and break the connections. So nothing is connected anymore. Set-driven keys usually also used for things like finger setup, or maybe even tail setup if you wanted to have some specific control over what you can achieve with those. Cool, and really quickly we'll take a look at the expression editor. I'm not an expert on it, so I will just show you very basic stuff you can achieve with it, and then you can go and investigate it a little bit further from there. So let's say I will create something. Or maybe actually, I think 4 will be enough for this particular exercise. So what I want to do from here, I want to be able to move those cubes, but I will only be controlling this one. And we will have to write an expression, so we'll have to write a piece of code that will be controlling this sort of movement. And I will be just creating that expression on this particular object. So for this, we will have to go under Windows Animation Editors and Expression Editor. And over here, you will see that we get the object we just had selected, and we have different attributes we could work with. So what we actually want to do is we want to say that whenever we're moving this in X, those guys will be moving, and we will probably multiply the amount of movement we're getting out of them. So let's say first we try something like connecting all of those together, so that whenever I move this one, the rest of them move as well. So what I can do is just to say that p-cube1, so here is its name. Also, I can click on different attributes like this translate X, and it will show me what the code for this particular idea should look like. So I can say that p-cube1 translate X, which can also be renamed to tx, and I will understand this, or you can just for now use this translate the proper code translate X. But actually we will not start with p-cube1. We for now we're just worried about the translation of those three guys, because this one will be the controlling one. So p-cube2 translate X equals p-cube1 translate X, and we will have to add a semicolon if we wanted to add any type of code after this one, and we don't want to do that, so I will just copy and paste this line. So let's just create this one and see if it works or not first. So we'll go and create, so let's see what happens. What I expect to happen is that when I move this cube, this one will just follow, which it does. That's really cool. So how do we go back to this expression we just made, because it's not showing up anymore? We'll just have to go on the select filter and we'll go by expression name, and it was our first expression, so just click on it and you can get back to it. And what I want to do from here is I want to do the same setup for the other two cubes. So it's going to be my p-cube3, and I know what its name is just by looking at the outliner. And we'll do another one for p-cube4 as well, and we'll just click edit. So now we should be able to control all of them with our first one. But let's say we wanted to do something a little bit cooler, so you can use maths here. So we can say that each next one will be moving slightly faster or slightly slower, and that's really easy. We can just say multiply by 2. Maybe multiply by 4 and just see what happens from there. So you can see we're starting to get this pretty cool type of behavior. And we can go with something a little bit more like this as well. So now, as you can see, our first one is a little bit too slow, so it doesn't move properly. So you can do all sort of crazy things with it. So this line will be our division, so we could divide this movement by some type of a number. Just click edit and see what happens from here. So we just expect it to be slower than the original movement of our cube. You can also, instead of, you can see how I'm repeating this value over here. What we could do, we could introduce an integer, so we could introduce something like a value that will be used by all of them. So instead of having to retype this number, we could just have an integer controlling this, and we can put this integer onto this object as well. So let's say we created a special attribute for specifying the speed of the other objects, and we can do it really easily by using our attribute editor over here. So let's do it really quickly. sorry, actually not attribute editor, we're looking for add attribute. So it's new window, and what we can do is we can add custom attributes to any objects in the scene. So I just want to add something like a variable on the subject that we can change that will specify the amount of speed those guys will be getting. And then we'll have to change this formula a little bit as well. So let's say we go here and we create a name, and we'll just call it speed. And for the minimum and maximum, we'll just leave it as it is, so we don't really have to specify anything, and the default 0 is fine. And should click add from here, you will see that now we have the speed value or attribute on our object, which is not hooked up to anything. So, you know, if you started manipulating it, I'm just clicking on this and middle mouse dragging on the screen, if you're wondering how I'm doing this. So nothing happens because it's not connected to anything. But what we can do here is we can say that this will be our p cube 1 dot speed, and then we'll multiply it by something like 2, 3, and 4. So just that we get a little bit kind of different amount of movement. And we can also probably use brackets for this one, just to let Maya know that we want them to be calculated in unison. And we'll see if it actually works in a second. Let's say edit. Okay, so we have an error. Let's just see what it actually is. So we can click on this mel, so script editor thing, and just see what it's complaining about. Oh, okay. Yeah, so it's looking for a variable. My bad. So let's introduce a variable which will be taking the value out of our cube. And let's call it speed. And let's say that it's equal to p cube 1 dot speed. And let's replace it over here. And hopefully this will work. Cool, so I think the problem was that it's actually lowercase speed. Let's close this and close this. And let's see if it works at all or not. So the speed is set to its default value at the moment, so it's at 0. So I expect nothing to happen. Let's see if we set it to 1. Cool. So we'll start getting this proper behavior. If we set it to 2, it's even more of a drastic change, and you can see it from distance. You can say it's 4, for example. It should be really easy to manipulate them now. So the first cube moves a tiny little bit, and the rest of them just kind of fly away. Going to set it back to 1. Awesome, so that's the basic idea behind using expressions. You can put them onto objects, and you can manipulate other objects in the scene as long as you know their names. So it's really easy to kind of look them up in your outliner. You should be able to use basic maths when it comes to expressions, but I also recommend to look up how to use MEL or Maya Embedded Language, because this is what our expression editor is using by default. And you can do a lot of really cool things with it, just as long as you have time to kind of experiment with it a little bit more. You can specify different types of conditions, so you can say that, if I move this to negative x, for example, only then I want something to happen with the objects I have connected to this particular object. So you can use your if statements, you can use your while statements, if-else statements, and things like that. So that's a little bit more technical, more for people who are interested in that sort of side of things. So I really encourage you to investigate this a little bit further, but I understand it's not for everyone, so if you're not interested, maybe just try and do this exercise just to see if you can achieve the same result. That's it for this lesson. Thank you so much for watching, and I hope to see you in the next video.